So now we're going to talk about binary ionic compounds, type 2 metals plus nonmetals. So in general, it's not possible to use the periodic table to predict what cations, what the charge in the cation is that are formed by transition metals, or the main group metals that are not in group 1 or group 2. Furthermore, unlike group 1 and group 2 metals, these other metal elements usually have more than one kind of stable ion. You might have heard things like ferric or ferrous. So those are down here, right? Or cupreous or cupric. So they can actually form more than one type of stable ion. So those are what we call type 2. Now, in the last I grouped representative metals, and basically, even though I was talking about type 1, the representative metals, for the most part, you can figure out what type of ion that they're going to be. It's very stable. Now, there's a few that you would think that you can't tell what they're going to be, but you absolutely can. And those are the aluminum, the zinc, and silver over here. You can see they're in a nice line that helps you remember them. And essentially, these two transitional metals, you can tell they're pretty much very standard in the form of the type of ion that they form. This is +3. This is, you can think 3, 2, and 1. Liftoff, right? So those are very standard, and so we essentially name them like we do the type 1, okay? A lot of the other transitional metals are not that stable in the terms of not stable, but they are not always predictable. So, sorry about that. So what we're going to do here is we are going to go over examples of the ones that aren't. So we can give, for instance, here, smaller again, about that. If we're looking at iron, for instance, and iron can be found right here, right? You can give it its name. The +3 examples, right, is ferric if you're in your name, but you can also name it as iron and then the Roman numeral 3, right? SN over here. Tin, that one is the +4, and you can put it tin Roman numeral 4. Or copper, that is right here, is copper 1, depending on if it's +3, +4, +1, or even +2. You can do like 2 in there. So you can easily name it that. That's the modern system. The old system used to use different endings depending on ion. So OUS endings refer to the ion with a lower charge. IC refer to ions with the higher charge. Of course, I think the 3, 4, and 1 are a little bit easier to deal with. But we're going to go through here and kind of name some of these. So let's start. In this class, we will only focus on basically the modern stock nomenclature, just to let you know. So let's start like I always do with, let's look at aluminum, and we can figure out, remember what I said about aluminum? Even though this guy is predictable, right? So he is, what do we remember from last time? What was he? How many does he lose? 1, 2, and 3, right? So aluminum is 3 plus, and then the chlorine, right, is 1. And so this, we can is basically the nomenclature we already learned, right? So it is silver chloride. The IUD here, right? Let's try a different one. So here is our iron, and here is our bromide. Now, how we figured this out, we look at the charges to figure out how many we would have. So this one is -1. Right? And then this guy, you're like, okay, how many is that going to be? Well, if we have 3 bromides, then we would need a charge of 3 here, right? So basically, then we would write iron 3 bromide. We still do the IDE at the end that we did in the last one. So here we are predicting what the name is based on, we're looking at here the actual molecule, and then we're thinking about charge. Let's do another one of these. So here we have copper, over here, not sure what that is, and nitrogen over here, right? So we have 3 of these. How many? What is nitrogen's charge to be stable? It's 1, 2, and 3. So it's -3. Well, we have copper here, and we have 3 of them, right? And they're going to be positive. So essentially here, then if we just have copper being just +1, then we end up getting enough charges here. So we'll write copper 1 nitride. And let's try this other one here. Oh. Cool. Okay, so the last one, we're going to look at chromium, which is right here, and sulfur, which is right here. Now, to let you know, we have 3 sulfurs, right? And we have 2 chromiums. Well, let's see what kind of charge we have on sulfur, right? 1, 2. So this is negative, right? Well, we already have for here, right? 3 times -2 means that there are 6 negative charges here. So what do we need to do to this guy to make it equal to 6 protons or positives, right? And if you said put a +3 on it, then you would be right. So then it is chromium 3 sulfide. And the IDEs are all at the end. So that's how you write the name from the formula given. Let's move down and write it based on if they give you the name. And I always get on here and look through and try to find and do everything on my periodic table. So here's my chromium, and they're basically saying that this guy, because it's 3, right, is this, and oxygen, we know is, sorry about that, -2. So from here, we have +3 here and -2. What do we need for those both to be the same? Well, if you remember, we're going to have them equal to 6. So that means how many oxygens do we need? 3 oxygens, right? And how many chromiums? 2 chromiums. So then we would write this Cr2O3. I hope you're starting to figure out how we do this by using the periodic table and going through each one of them. So let's do the next one, 10, which is over here, right? And this says 2 on it. So on here, we're going to put SN, and it's +2. And the fluoride is here, and the fluoride is F -1, right? So essentially, for us to have it to be balanced, we would need fluorine to make it equal. So you would just write it that way. So let's go to iron to oxide. So iron is here, and it says, iron 3. So then we know looks like this. Iodine here, which is -1. So then essentially, for them to be balanced, we would need 3 of these. So you could put iron, 3 iodide. Let's go to the next one, zinc nitride. So zinc is right here, and you should notice that we don't have any weird positive charges or any, Roman numerals there. So we're going to look, we're going to see from what our nitrogen ion makes, basically what we have here. So we have 1, 2, 3. Okay. So when we were talking about above, we mentioned that basically zinc always forms a certain ion, which this guy always is +2. Remember how we did? I showed you, let me put it in a different color. This, and this, and that how it went down, and it was 3, 2, and 1, right? So that's how you can remember the zinc one. And so zinc is always +2, nitrogen is -3. So again, how do we make this equal? Well, the first number they both multiply into is 6. So then we know that this would be 2, that would be 3, and you would write it like that. Copper 2 bromide, copper it's 2. So you know it's +2. Bromide, 1 to make it neutral. So if you look, then you know that you need 2 of these. And our last one, Cobalt Ii Oxide. So cobalt is here. We know that it's 2 underneath it. So +2 oxide is -2 to get it stable. So it's as easy as CO, C-O, big O. So that gets us basically through our next set that were the basically the transitional ions. And so the next thing that we're going to look at is polyatomic, and that will be in the next video. Thanks, guys.